Hello world, I am Rohit and today we'll be solving the project 1A Nights of CS50 AI. In this project we'll solve some of the logical puzzles using propositional logic. The background for this puzzles is logician Raymond Smullyan published what is the name of the this book, which is a book, and it contained logical puzzles among which some puzzles named knights and knaves. So this project is derived from there. We'll be using expressions like and, not, and or as it was shown to us in the lecture. I'll be explaining each of the puzzles as we implement them in the code. And before we get into the actual code, just a small note that we do not support any kind of plagiarism and do not just copy and paste the code in your work. I highly recommend trying it out first by yourself and then seeing the solution. And if this video helps you, consider putting a like and also comment for feedback. And also for this project we need to get it right for 100% of the code or else it will not pass. So now let us get into the code. Here we are in VS Code and the first knowledge that we are going to write in code is that a person can be a knight or he can be a knave but not both. So let us write the code. So let us do it first for A. So A is either a knight or a knave but not both. We'll do the same for B and C. We have implemented our common knowledge base, which we will call in each of these knowledge bases because it is same for all of the puzzles as given in the problem itself. Here it is. Each character is either a knight or a knave but not both. Now we'll implement our first puzzle, which is puzzle 0, in which A says I am both a knight and a knave. We know this can't be a possibility, so A must be a knave, but we cannot explicitly write a knave here because it is against the protocols of this project. So let us implement the puzzle using propositional logic only. What we'll do here is we want to imply if A is knight, then what A said is correct, which is A is both a knight and a knave, and if A is a knave, then what is said that he is both a knife and a knave, then he is incorrect. So let us implement the propositional logic. So if A is a knave, we can simply put a not before the AND logic. We forgot to add the common knowledge base, so let us add it. I think we have implemented our puzzle 0 successfully in knowledge base 0. Now let us implement the next puzzle, which is puzzle 1, in which A says we are both knaves and B says nothing. So what it means is, if A is a knight, it implies that A is a knave and B is also a knave, and if A is a knave, then they are not both knaves. So let us implement the propositional logic. First we will call our common knowledge. Now I think we have successfully implemented puzzle 1 knowledge base 1. Now let us implement a knowledge base 2 in which A says we are the same kind. So if A is a knight, A is a knight and B is also a knight. That is one possibility, and another possibility might be A is a knave and B is also a knave. So let us implement the propositional logic for A first. So what we did here is, if A is a knight, then A and B must be of the same kind. So one possibility is A is knight and B and is knight, or another possibility is A is a knave and B is also a knave. And if A is a knave, we can simply put a not before the or propositional logic. Now let us implement the propositional logic for B. Here B says we are of different kinds, so this will largely be the same, but here we'll type A knight and B knave, something like that. So let us implement for B. So what we did here in B is, if B is a knight, A and B must be different as stated here. So if B is a knight, A is a knave, either A is a knave and B is a knight, or A is a knight and B is a knave. And we can simply put a not propositional logic before the or propositional logic if B is a knave. And I think we forgot to add our common knowledge, so let's add it. Now I think we have successfully implemented the puzzle 2 inside the knowledge base 2. Now let us do our final puzzle, which is puzzle 3, in which A says I am either a knight or I am a knave, but you don't know which. I think we have already implemented that this logic in our common knowledge, so we do not need to implement that again. We can just simply type common knowledge here. Next B says A said I am a knave. It involves two of the characters, so it will be a bit difficult as to say. So let us try to implement it. It will be something like, if B is a knight, then it will imply certain things, one maybe two things. So let us try to implement it. So what we did here is, if B is a knight, it implies two statements, which is, it implies first, if A is a knight, it means A is a knave. It implies A is a knave. And another implication is, if A is a knave, it is not a knave. I know it is a bit confusing, but this is what B says in puzzle 3. And if B is a knave, which we will do here, and if B is a knave, we will use the not propositional logic before the and propositional logic. Now B also says C is a knave. This is a simple one, that implies, if B is a knight, then C is a knave, and if B is a knave, C is not a knave. So let us implement it. So if B is a knight, C is a knave, and if B is a knave, C is not a knave. Now C says A is a knight. It is also simple to implement. We'll follow the same pattern for B and C. So let us implement it. I think we have successfully implemented the puzzle 3 inside of knowledge base 3. Now let us run our program puzzle.py and also run check50 afterwards to check if we have implemented our program correctly. So as you can see, the program correctly outputs whether A, B or C is a knight or a knave. So the program is probably correct. Now let us run the check 50. As you can see, we have correctly implemented all the puzzles in our knowledge bases correctly, and the program is absolutely 100% correct. You can go right ahead and submit it using the submit 50 command. This was project 1A Nights from CS50 AI.